Welcome everybody. My name is Vlad Cârcu, and we're going to look today at how we can enforce best practices through code design. And best practices is something which we discuss each day, either in educational videos, in conference talks like this one, in code reviews with our colleagues, and also in virtual coffees over Zoom. And we have a lot of sources of information which are really great, but no matter our experience, keeping a code base free from hacky solutions requires a lot of attention, of patience, and energy. And we also need to use tools which help us in this endeavor and which tell us when something's not done right. But the disadvantage with these tools is that they are run after the code has been written. And what we'll be looking at today is how to do this before actually writing any code. My name is Vlad Cârcu. I'm a senior software developer, team lead, and community lead at Cognizant SoftVision. As a community lead, I'm involved daily in knowledge sharing initiatives, which aim to help our colleagues grow and develop their skills. Personally, I'm passionate about, from a technical standpoint, I'm passionate about everything related to patterns, all the types of patterns which I can find, and also about the problems they solve. And the fact about patterns is that they sometimes challenge the way things are currently done. And that allows us to better understand the underlying issues and also the solutions. And the challenge today is about how we design our code. We'll be looking first at the usual problems which we face when evolving our code. Then we'll choose some objective, hopefully, criteria to judge the success of design approaches and also come up with a code design alternative which enforces those criteria by default. Then we'll have a short look at a few lines of code to see how we can implement that and how that is different from our daily activities. And at the end, we'll look at how shifting to another approach will have a positive impact to projects in general and also to projects with microservices in particular. I think the most popular way to structure a new software project is by using a layered architecture. And this example, I'm sure it's very simple, but it illustrates a regular web application, and there are probably millions of those. We have three layers: the UI, the service, and the repository, and each layer calls the next. And each layer is supposed to have knowledge only regarding whatever it implements, and what the layer below, directly below it, exposes as API. And when we talk about API, we don't refer only to the methods, the behavior, but also to the models, the objects which reside in that layer. And this is a good design because it uses the concept of separation of concerns. Each layer is tasked with a different concern, and this leads to decoupling the code. But then what happens when we try to evolve it? What happens when time passes and we have more use cases to implement and we do that? How do we ensure that this initial design remains unchanged? And I'm gonna look here at two options. First, I'm gonna think what happens when we're building it top to bottom. So we start with the UI layer, and we define our controllers and DTOs. And then we get to the service part, and we pass the DTOs as parameters to the service layer. And then we also add the repository, and somewhere in the middle between the service and the repository, we also do some mapping between DTOs and entities. And that sounds pretty legit, I'm sure. I've done it before, I'm sure most of you have done it before. But what we've done right and straight from the beginning is that we've coupled our UI and service layers, because the UI is calling the behavior from the service, but the service is also using the model defined in the UI. And that's a cyclic dependency right there between your two layers. An easy way to solve this is to split your whole code base into modules. And tools which use modules like, let's say just for humor, Java modules, but also Maven modules and Gradle modules, they don't allow circular dependencies. And that's a first way by which you can ensure that your design is cleaner just before writing it, thinking about the structure. But let's look at the other way around. When we're building our application bottom up and we start by defining the database entities first, we usually do that with JPA. Of course, this, I'm going to go off track a bit here. This talk is centered about Java because I am a Java developer, but these concepts happen just the same in any other language. So even if you hear JPA, there's probably going to be an ORM solution in your programming language of choice, which you can relate to. And the fact is that when we start with the database, we define our entities, and then we pass them up to the UI layer through the service one. And the second mistake we did also right off the bat, so when we're writing the first lines of code, is that we've coupled the UI to the repository, and that shouldn't happen. And there's no way to enforce it because of its chained nature. The layered architecture allows you to couple your repository to your UI very easily. And that's not all. Let's say that we start a small project. For now, it's just a simple CRUD, and everything which you're saving is also everything which you're showing. It's a bit of what you see, what you get. But then something changes. Let's say it's a small change. You have in your repository a first name and a last name, and you need to show a full name in a certain screen. And you end up with this derived property, which you either calculate each time, or after you're bored of doing that calculation everywhere, maybe, I don't know, for performance reasons, you think about alternative solutions. And an easy go-to solution is to add the transient field to the entity, because that doesn't get persisted. So your database won't have any problems with it. But what you've done there is that you've taken logic and a constraint of the UI, and you've implemented it in the repository. And you can see that by doing all these small mistakes and small choices along the way, and doing them wrong and lacking that enforcement of rules, you end up with a big ball of mud. And in a few years, when the technology changes, you're going to say, oh my God, I cannot change the technology because it's too complex. I'm going to have to rewrite it from scratch. And that's, to be honest, good for business, but it's bad for ethics. So let's keep building on the suspense a little bit. And let's first look at what we'd like to enforce in our code. And for this, we don't have to look a lot because Bob Martin has done his work very well by defining the 11 principles of object-oriented design. And the first 5 are related to class design, and they're called the solid principles, and everybody knows them, standard interview questions. There are 3 more centered around package cohesion. So what do you put in a package, and how do the classes in there relate to one another? And also 3 more around the package dependencies. So how packages depend upon each other. And I extracted out of these everything related to dependencies. So we all know the dependency inversion principle, depend on abstraction, not on concretions. And I'm not going to go into details there. but then the other three ones are the ones related to package dependencies. And the first one is acyclic dependencies principle. So between your packages, there should be no cycles. A build tool like Maven or any build tool which uses the concept of modules or packages or something like that enforces this by design. So that's a good reason to use such tools. But then we get into a bit more strange territory. We have another principle called the stable dependencies principle. And Uncle Bob suggests that we should always depend in the direction of stability. But how do we measure stability? And he came up with this metric called instability based on the number of dependencies a certain module has. Incoming and outgoing dependencies, they're also called afferent, the ones which are incoming, and efferent, the ones which are outgoing. But we're going to call them incoming and outgoing because otherwise I'm going to get lost between the terms. And how you calculate that is the number of outgoing dependencies over the total number of dependencies for a module. So if we do that calculation, if we only have outgoing dependencies, then our instability will be 1, and that's a perfectly unstable package. If we're going to have no dependencies at all, then instability is going to be 0, and that's a maximum level of stability for that package we have there. Then we also have the stable abstractions principle, which says that builds on top of the stable dependencies principle and says that abstraction should increase with stability. So the more stable a package is, the more abstract it should be. However, Uncle Bob came up with this metric of abstract classes over total number of classes, but he also gave a disclaimer that it's not a perfect metric and that this could be adapted to whatever context we have at a certain point. And we're also going to be looking at that in our demo today. Okay, so what would be the solution to start enforcing these design principles right off the bat? And a suggested solution is the hexagonal architecture. And this is a concept which was formalized by Alistair Cockburn. And Mr. Cockburn is, along Martin Fowler and Bob Martin and Ken Beck, is one of the original proponents of Agile. And according to him, the purpose of hexagonal architecture is, and this is a quote, allow an application to be equally driven by users, programs, automated tests, or batch scripts, and to be developed and tested in isolation from its eventual runtime devices and databases. And I think that quote sums up what we all wish for all of our applications: to work in an organized manner, to work on every track in parallel, back-end, front-end, testing, and integration without having to communicate over teams. So as Mr. Cockburn puts it here, in isolation. And what's pretty cool about this approach is that it kind of shifts the idea. We don't have a top-down approach, a left-to-right approach, as you could see in the layered architecture. It's an inside-outside approach. And this is also the reason why it's called hexagonal, because the hexagon is a good shape to showcase this inside-outside perspective. I also imagine it was pretty hard to say something like circular architecture because you have the circle, it's still inside, outside, but this concept is totally different because it totally opposes the circular dependencies. Let's have a look a bit at what's inside our hexagon. So inside, we have a domain and some ports. And the ports describe how the domain expects to interact with the outside. We have input ports like the data port, and we also have output ports like the presentation port. And the ports are abstract components. They describe the domain's expectation on how to interact, but they don't actually implement anything. And the domain itself is very important because that's what makes your application special. That's where your business logic, your business objects, where your whole application actually resides. Everything else, which is outside the hexagon, that's infrastructure. So for each port, you may have one or more adapters, depending on your infrastructure dependencies. For example, we have a data port through which the domain obtains data, but then that data can come from a repository, and in that case, we build a repository adapter for it, or from a service, in which case we from another web service, in which case we build another service adapter. And it's exactly the same way, the other way around for the controller. Let's think a bit about our previous example with the transient properties which we ended up adding in the repository. Can we still do that now? No, we cannot, because the objects in the repository cannot be propagated to the UI layer. There is no direct dependency between or indirect dependency between the UI and the repository. The whole hexagon in the middle, the domain and the ports, they work as a break in the dependency. So it's not left to right, it's not sequential, it's not chained anymore. It's all the dependencies come to the domain, and there are no outgoing dependencies from there. So it's a very small change. It's a very small change, and it's a very subtle change. And by designing your code like this, you basically end up enforcing your design choices. And what changed is just the direction of the dependencies. Talk about dependency inversion here. And what I like especially about this architecture is that first, you're thinking about where a piece of code should go. And it's pretty clear. You say, okay, this needs to be in the repository, and you put it in the repository, and that's it. You cannot do anything bad from there because your choice has been enforced subtly by the design of the code. In the layered architecture, you're going to say, okay, this needs to go in the repository, but then I'm exposing my repository through the controller. I might need to do something about that as well. Maybe I'm not going to put it in the repository. I'm going to put it somewhere else. And that it all goes downhill from there. And that's because you have the opportunity to make a choice, which shouldn't be the case. Okay, let's see how this hexagonal would look in the code. And for that, I've prepared a dummy scenario. And we can imagine that we have a car rental service, which manages rentals of cars. And that needs to communicate with another service called the core service to get its users and cars from there. And also it needs to communicate with the database in which to persist all the rentals. I'm not going to go into much detail over the tech stack used, but it's basically Spring Boot and a bunch of other libraries which make your life a lot easier. And what you would expect as a module structure, it's a Maven project, and what you would expect normally in a layered architecture would be to have your repository and client for the other service in separate modules. Then the service would depend on those, and then the controller and on the service, and then the Spring Boot module on everything else, just to ensure that the dependencies are properly bound at runtime. Okay, and what's gonna happen, what you're actually going to see, you're gonna see that the service is actually our domain, and that everything depends on it, the repository, the client, and the controller. And then Spring Boot comes to do just the same as for the layered architecture. It comes to provide that dependency injection context. Okay, it's gonna take 1 second to shift my screen. Well, maybe not one, but who's counting? And let's see, screen 2, screen 1, share. Perfect. Okay. I suppose everything is fine. This screen is visible. Yes, it is. Let's close everything and just concentrate on the project. We have a Maven project, and you can see all the modules here: boot, client core, controller domain, and repository. And we're going to start with the central one, with the repository. What do we have in the repository? First, we have the domain objects. So our domain needs to do car rentals. So it needs to work with cars, with users, and with the rentals. And that's basically what's captured here. The objects are pretty simple. There's nothing special about those. You can see all the Lombok sugar, which is added there for brevity. And then we should also have some behavior. And for that, first, we're going to look at our output port. And our output ports, in this case, the behavior which we expose is to create a new rental. And the nomenclature used is not services, but use cases. And this is the use case, the rental use case, which has this create new rental method. We also have a default implementation for this use case. And this is a debatable topic. You can have an implementation in your domain, but you can have it outside your domain as well. The main point why I chose to have it in the domain here is because I only have one implementation. That's one thing. And because, as you can see here, this implementation is totally shielded from the outside. It's domain logic here. It's whatever business logic I have to implement for this create new rental functionality. That's all there is to it. And I can keep it here just so I don't create too many packages, and I don't leave this domain to be very anemic, only with abstract classes and no behavior at all. Okay, and what do I have here is the method, and this uses the ports, the input ports, to get its data and to persist it. You can see from here that I don't know where I'm getting anything. So the user port is an interface, the rental port is an interface, the car port is an interface. And they're all ports. They don't say anything about infrastructure, and that's my whole domain logic. And you can imagine how easy is and isolated is to write tests here. Also, if I'm going to look at the dependencies, I'm going to see that I don't depend on anything. This is half a lie, because I get some dependencies inherited from the parent POM. But theoretically, so I do have a dependency. If I'm going to look in here, I'm going to see that, okay, I depend on Lombok. I depend on Spring to use this component annotation. But if I'd like to, I could get rid of this as well. I could just create it somewhere else, maybe in the controller. I could do that whole binding, or most likely in the boot, where you put everything together and where you would have Spring Boot related configurations. I could just do the binding there as well. And then I would have my whole domain logic completely free of any dependencies. That would be a very pure way to write your code and to separate it completely, not only from infrastructure, databases, APIs, and such, but also from technology, whether you're using Spring Boot or Vertex or J2EE or microprofile or whatever you're using there. Okay, let's look a bit at how these ports are implemented. And we're going to start with the car port. And we're going to see that it's implemented by a car REST adapter. And this has a car API, which is a Fein, it's a Fein interface, it's a Fein client, it's generated code. And it uses that car API to get the car. And that's it. Let's also look at our rental adapter. Okay, rental DB adapter. And you can see that this is a separate implementation for another port. And this one connects to a database through a rental repository. And that's it. That's it. So you can see how that dependency inversion principle is being applied here. It's not that you have the definition and the implementation in the same package, like I chose to have it here for my domain. But you have the definition here in your source package, and in your domain, you have the definition of the port in the domain, and you have the implementation of the adapters everywhere else. And that makes sure that all your infrastructure related functionality depends on your domain. And that's true dependency inversion, which we should use in our code. I won't go into the controller because too much, because the code there is really just the same as you would in another regular application, because the direction of that dependency hasn't changed at all. And that's about it. What you can see from here, for example, the Spring Boot module, normally it would only need to depend on the controller, but here it needs to depend on everything else: controller, repository, and client core, because these packages, they don't have anything in common. They each do their own thing with their own data model and with their own responsibilities and with their own underlying infrastructure. You might have noticed, but you're going to need some extra mappers. So that's something which you're going to have to implement, because basically in each module you have your own data model which is used there, and you need to translate that to the domain model, and that's the extra bit of work which you need to do to enforce the design you're choosing through before writing the code, writing mappers. But if you're using a tool like Mapstruct, like I used here, then that shouldn't be any problem. Okay, let's go back to the other screen and continue the presentation. And right now, having seen the code and having talked a bit about the concept, I think it's safe that we can compare the layered architecture and the hexagonal architecture as far as enforcing these 4 principles defined by Uncle Bob. And as far as we do the dependency inversion principle, we sort of do it in layer because we always have this implementation and definition implementation, this service IMPL type of pattern. But I'm going to do a small joke here. I'm going to be mean. it doesn't do anything special. And we get a lot of times asked, especially by new guys, by junior people, why can't I do just write the class and not write the interface, especially when I have only one implementation? And that's a very valid question. There's no good reason for it. So we sort of do it, but no way we're doing it as it should be done to reverse an actual dependency between classes. We just do it to, I don't know, add a bit of an abstraction to our code. Then we have the acyclic dependencies principle. Possibly this one is implemented. It needs a bit of work. So either you're having very granular Maven modules, which is never going to be the case, or you can do this proactively, but also after you've written your code through the use of static code analysis tools. For example, IntelliJ or Sonar or any other tool which kind of looks at these dependencies and identifies maybe cycles between them. Then we have the stable dependencies principle. This is mostly driven by context. So I may be lucky and have my repository depend on less packages than my service, but it's not something which is guaranteed. Also, for the stable abstraction principle, there's a mix in all our layers. We have everywhere also abstractions and also implementations. So let's say that also by chance we respect this principle, but we only have respect because it's not going to be able to be correlated in any way with the stable dependencies principle. And that's the whole key there, that stability should increase, abstractness should increase with stability. And if you don't have that relation, then it means that you're not respecting that principle. For hexagonal, things are a bit clearer. Dependency inversion principle, yes. When you define your ports in the domain inside the hexagon, that's when you've implemented the dependency inversion principle. The acyclic dependencies principle, you're probably going to do it. I would say it's not a hard yes, because you might still have some circular dependencies between your packages, between the packages within a module. So there's no easy way to enforce that unless you get to build modules at the more granular level. There's the stable dependencies principle. The domain is perfectly stable, as we've just seen. It had no dependencies on other modules, and everything else, everything which is external, is just the same as with the layered architecture. The difference being that they all go their separate ways. There is no chain there. There is no relation there. So you're looking at the UI compared to the domain. Yes, it's the stable dependencies principle is respected. Then you're looking at the domain and the repository. It's just the same. And the stable abstraction principle, that's done as well, because you actually have all your abstractness in the domain, you move it there, all the definitions which are particular to your code, and everything else is outside the domain. Everything outside the domain is definitely less abstract than what's inside your domain and inside your ports. So we can see that by using this type of approach, we can actually enforce just through design all these best practices in the most simple and elegant manner possible. Okay, let's say that you're doing this. What should you expect as impact, aside from writing the mappers? I'm going to concentrate on the positives as well. If you're building a microservices layered architecture, architecture, and you have a bunch of microservices there, then VMware had this concept of 15-factor app. And the 15 factors for cloud-native apps build on the initial 12 factors for cloud-native apps defined by Heroku. There's also a short book on this. It's free to download online. And the first factor which is impacted is the API first. And this states that whenever you're building a microservice or a cloud-native app, you should start by defining your contracts for that service. You should start by defining the API. And this will allow then working in parallel on testing, development, and also integration, the fact that you have that contract already written down. And this is something which the hexagonal architecture does internally by default through the ports, through the ports and the use cases. Those are the API for your domain. And this leads to having this contract-centered way of thinking within your team. And it's very easy for the developers to understand that it's the same concept they are using for two different things. The second one is the backing services, and that refers to services which shouldn't make any assumptions about the system they use. And that's happening perfectly through hexagonal as well. You have your whole infrastructure completely separated from your actual code. And what that means is that your domain doesn't care if it gets its data from a cache, from a database, from another service, as long as that contract is implemented. It's not that you don't care where it's deployed. For example, if it's a database which is deployed locally or in cloud or behind a firewall or somewhere or on the same machine, you don't care about that, and that's what backing services is about. You don't even care whether you're using Spring or Vertex in your internal code, and that adds an extra layer of abstraction right there for your code. There's another thing which I would like to mention. There's also some impact to projects in general. And there's something called the project paradox, where we need to make decisions about how a project evolves. And the biggest decisions we make at the beginning. When we decide to start a project and use a relational database, well, that's a constraint which, even if it's possible to change it later, it's going to be proportionally difficult with the number of features you've implemented up until then. And that's the whole thing about impact. You make the decisions, and statistically, you're going to get half of them wrong. And then that creates some technical debts on design debt, which needs to be tackled in the future and which is expensive to tackle. And even more important, because it's expensive, you always get pushed back on your initiative. And the hexagonal architecture has this built-in flexibility. You can concentrate on your domain. You can define your expectations for a very abstract repository. And then when you actually decide on what you're going to use, you're going to do the implementation. In the meantime, you can work with any stub implementation you'd like. And that's very, very helpful to have this flexibility for the future. I've also added some resources and interesting reads to the presentation. It includes a use case from Netflix showing this exact flexibility I've been talking about. Also, let's say that, okay, you don't want to use hexagonal, it's too complicated, but I have two things to ask you. First of all, never send DTOs as parameters to the service layer. And second, never propagate DB models to the UI layer. And by doing this, without knowing, you're going to be doing hexagonal. And After you've done it, please let me know if it worked out for you. That was all about my presentation. Here are my contact details, and also you can also scan it with your phone or take a screenshot or scan it later. I'm gonna start checking for questions right about now. Okay, yeah, we have one from Emmanuel. Yeah.
Yeah. Emmanuel asked something about the mapper.
Yeah, I see that it's been answered. Yes, it's Mapstruct. It's a very performant mapping library. There's an article about benchmarking mapping libraries on Bildung, and this is at the top of the benchmarks. And it's also very well documented and easy to use. I've used it a lot. I really like it, and that's why I've used it. And Emmanuel also says, you're right, but without the Mapstruct library, it is so much code to write for mappings. Yes, it is. But then you write that code up front and you don't have any technical debt. I'd rather write a simple mapper or use a mapping library, because then I don't have to write anything at all, than to have to refactor my whole domain logic a year down the road. So I don't know. It's how everybody thinks about their project. It's a choice at the end.
I have a question. If you have to refactor to this, is it done easily or?
Yes, I would say it is done pretty easily. I'm gonna shift a bit to my other screen to show you some code. Okay. So if you're thinking about what's different from a regular Spring Boot application, you would have here the service and the service implementation, and you wouldn't have these ports because they would be defined somewhere either in client core or in the repository. Most likely you wouldn't have them at all, because from this rental use case, I would have to call directly the repository here, my rental repository, and also the car API, and that's it. So I would actually have to call those components directly here, but the code itself wouldn't be any different. So instead of user port, I would have a user API. Instead of car port, I would have car API, and then the method calls would be maybe slightly different. I dare say that it would be even uglier, because here in the service, I would have to do the mapping between whatever comes from the external service to whatever I need to push later to the to my domain object. To my let's keep it simple, to my domain object, and I would have to do the mappings here as well, which would make the code a bit harder to read. But that's it. All you need to do is define these ports. Of course, if you have an application with 100,000 lines of code, the effort is going to be proportional. But you can experiment with one use case, see how that works out, see how long that takes you, and then see whether it's worth gradually migrating. But other than this, defining your ports, there's nothing else to be done, to be honest.
Okay, thank you. And we have Emmanuel on a strike of questions. He's asking you if your demo project is publicly available.
Yes, the demo project is publicly available. Just a second to shift screens again. Okay, it's publicly available, and I've also linked it in this presentation. You can see here what this Vox Days demo branch, you're gonna find it there, and it also has these naming conventions, and it's a bit more polished from my perspective. You do need a database to actually run it, but other than that, it's latest Spring Boot version, Java 17. There was no opportunity to implement any Java 17 APIs there. It's online.